Hello students, in this video I am going to discuss some important numerical problems from chapter Gravitation of class 11 physics. All the questions are very important. They are application based questions. So watch the video till end. Okay, the video is very interesting. So let us now try to understand question number 1. A solid sphere of uniform mass capital M and radius capital R applies a gravitational force of attraction equal to F1 on a particle of mass M placed at a point P, distance 3r from the center of the sphere. A spherical cavity of radius r by 2 is now made in the sphere as shown in the figure. The sphere with cavity now applies a gravitational force F2 on the same particle at P. Find the ratio F2 by F1. So first of all, we will find the force F1 which is given by gmm by 3r square, and it finally becomes gmm by 9r square. Okay, here you can see the distance is 3r between the center of solid sphere and the mass at point P. So let us suppose that m dash be the mass of the cavity, and m dash can be calculated in this way. You can see here the mass of cavity m dash is m by 8. Okay, now f dash, that is force due to mass of cavity at point P. Okay, force due to mass of cavity at point P is given by f dash equal to g m by 8 into m by 3r minus r by 2 whole square, which is finally gmm by 50r square. Now force on m due to remaining portion of the sphere can be calculated by taking the difference of these two forces F1 and F dash. So after taking the difference, we are getting 41 gmm by 450r square. Now take the ratio F2 and F2 by F1, we get 41 by 50. This is the required answer. Now question number 2. Okay. Question 2. 4 particles each of mass m are moving along a circle of radius r under the influence of mutual gravitational attraction. Find the speed of each particle. Let us suppose that v be the speed of each particle, and you can see in the figure there are 4 particles, particle 1, 2, 3 and 4, each having mass m. So first of all, we find the force on m due to particle 2 and particle 4. Here we can see that distance between particle 1 and 2 is r root 2, and this is the distance between 1 and 4 also. So force on 1 due to 2 and 4 is same, and let it be F, and the resultant of these two forces F and F be Fr. So Fr can be calculated in this way. The angle between these two forces is 90, so Fr is root 2F, and it is finally root 2 gm square by 2r square. Okay, now force on force on 1 due to particle 3 is f dash. So f dash equal to gm square by 2r whole square, which is gm square by 4r square. Okay, now you see these two forces Fr, which is root 2f, and f dash, these two forces are in the same direction, and the net force on 1 can be written as Fr plus f dash. So we can calculate it. Okay, this force will provide centripetal force. Okay, so we can write the net force on 1 which is root 2 gm square by 2r square plus gm square by 4r square equal to mv square by r. From here we can calculate the velocity of each particle, that is v equal to root under gm by r into 2 root 2 plus 1 by 4. This is the answer. Now question number 3. Question 3. What is the minimum energy required to launch a satellite of mass m from the surface of a planet of mass capital M and radius capital R in a circular orbit at an altitude of 2r? Okay. So let us now suppose that K be the kinetic energy given to the satellite on the surface of the earth to take it to desired location. So according to law of conservation of energy, we have total energy on the surface of the of planet equal to total energy at the desired location. Okay. So after taking total energy on the surface of the planet, that is potential energy plus kinetic energy, that can be written as minus gmm plus k, and total energy at the desired location is, you can see this one, minus gmm by 3r plus half m gm by 3r. From here we can calculate, that is k equal to 5 gmm by 6r. This much energy is required to launch a satellite of mass m from surface of planet of mass m and radius r in a circular orbit at an altitude of 2r. Now question 4. If radius of the earth shrinks by 2%, mass remaining constant, then how would the value of acceleration due to gravity change? So as we know that the acceleration due to gravity on the surface of the earth is g equal to gm by r square. Now taking logarithm of both the sides, we get log g equal to log capital G plus log capital M minus 2 log r. Here capital G and m are constant, so differentiation of the above equation gives dg by g equal to minus 2 dr by r. Since the radius of the earth decreases by 2%, so we can write dr by r equal to minus 2 by 100. Minus sign shows that radius is decreasing. Now percentage change in acceleration due to gravity can be written as dg by g into 100 equal to minus 2 into dr by r into 100, which is 4%. This is the answer. Question 5. A homogeneous bar of length L and mass capital M is at a distance d from a point mass M as shown. If force on small m is F, then find the value of F. Here you can see in the first figure the point mass. Here you can see this is the point mass, and the length of the rod is L, and it point mass is at a distance d from the one end of the rod. So here you can see I have considered a small length element of length dx and having mass dm. It is at a distance x from point mass m. Since mass per unit length of the rod is m by L, so mass of small element dm can be written as m by L dx. Now the differential force between element and mass m is given by df equal to gm dm by x square. Replacing dm, so we are getting df equal to gmm by l into x to the power minus 2 dx. Now total force on m due to the rod is given by F equal to integrating df within the limit d and l plus d. So we get minus g mm by l into 1 by x, and the limit is d to l plus d, and after putting the limit we are getting F equal to g mm by d into l plus d. This is the answer. Now question 6. A uniform rod of mass m and length l is taken. Find the gravitational field intensity at P at a distance d which is on the perpendicular bisector of the rod as shown in the figure. So in first figure you can see length of the rod is L, and we have to find the gravitational field intensity at point P, okay, which is at a distance d, okay, and it lies on the perpendicular bisector of the rod. So in second figure you can see everything has been mentioned here. First of all, we consider a small length element of length dx, okay, having mass dm, okay. Since the mass per unit length of the rod is m by l, so mass of the element will be dm equal to m by l dx, okay. Now gravitational field intensity at P due to element can be written as di equal to g dm by x square plus d square, and after replacing dm we are getting g by x square plus d square m by l dx, and which is along P to C, okay, P to C, you can see P to C. Here x equal to d tan theta, so dx equal to d sec square theta d theta, and x square plus d square equal to d square sec square theta. Now di can be rewritten after putting the value of dx and x square plus d square. We are getting di equal to gm by ld d theta, okay. Now net gravitational intensity at P is due to horizontal component di cos theta of di, and vertical component cancel each other, okay. Since you can see here the di is along P to C and it has two components, one in this direction and other in the vertical direction. So for the other element in the downward side, di will be two components. Di will have two components, one along horizontal, another along vertical. So vertical components will cancel each other. So net field, gravitational field, okay, total gravitational field intensity at P due to entire rod can be calculated by integrating di between the limit minus alpha to plus alpha, and the net gravitational intensity at P is due to horizontal component di cos theta. So we are now going to find the net or total gravitational field intensity at P due to entire rod. Okay, so I equal to integrating di within the limit minus alpha to plus alpha and replacing di by di cos theta. So we are getting gm by ld sin theta, and the limit will be minus alpha to plus alpha uh, after replacing the putting the or when we put the limit, okay, we are getting gm by ld into 2 sin alpha, and finally after replacing sin alpha we are getting 2 gm by d into root under l square plus 4d square. This is the answer. Okay, so thank you for watching this video. Thank you very much.